stuff. Okay. So whatever we are going to do today, it may not make much sense, because why we are doing a certain graph and all, you may not get a hang of it now. But once your first two BA classes are done, you can understand which kind of visualization can be used for which kind of analysis, right? But today, however, we will try to draw some graphs. We will pick up this graph, titles, headings like bar graph, this graph, that graph, and we'll just try to see how it is done. That's it. That's our aim for today. When we are doing stuff, when we are doing, let's say when we are doing time series, or when we are doing any kind of stuff, that time again these functions are going to repeat, right? So today's class will be kind of a net practice for all your future graph functions, what you're going to do with your BA classes, especially your first two BA classes, which will deal with exploratory analysis. All right. Just apply functions as well before we go to the graphs part. Some of the programmatic concepts which we just skipped, right? So what we'll do as a part of this is we'll see how to create functions and how to utilize them, how to make use of them, right? So in SAS, you have a concept of macros. So the idea behind macros is that you should be able to repeat certain set of tasks. So you should be able to repeat certain set of tasks in a given time. So reusability is the idea behind macros. Like again I said, macros may or may not solve the entire purpose of repeating the code. I am not sure about it. But in any language, any programming language, usually you have a feature called functions, user-defined functions. So creating functions, or I will call it user-defined functions. So user can write a set of lines which he or she feels that this task has to be done on a time-to-time basis, or they have to repeat this task at some other place of code, right? So every time you can't write all those 5 or 10 lines or 15 lines of code again and again. Keep it in a function, just go and reuse it. This is the idea behind going for a function, right? So what we'll try to do is we'll try to create a simple cube root function, a function that calculates cube root if a number is given as an input. So simply put, function is a set of statements that will take some inputs, process it, and give some output, or it can perform some task. So if I say cube dot root, please look at the syntax to create a function. I'll use the keyword function. Now this means we are creating a user-defined function. So function is a keyword which is used to denote that we are going for a user-defined function. So once we have written this, we should give the open and close curly brace. So whatever lines of code that you are writing should be within this curly braces. You can write any number of lines that you wish to, and that should be between these curly braces. And what you should remember is three things: inputs to your function. Technically, inputs are also known as arguments. Logic, or set of tasks that you wish to accomplish, and finally return the outputs. If any. If you have any output to give, you have to return it, or if you have to print something, you can print it. So here I'm going to create a function that can take one argument as an input. Like I can say a function x, it will take number as an input, and it will calculate the cube root, right? So please pay attention. So I'll say result is equals to, how do you usually find a cube root? Like if I have x is equals to 10, or if I say 81 for example, right? So cube root is x or any number to the power 1 by 3, right? Clear? Now take a perfect cube, like what's a perfect cube? 27 is a perfect cube, right? 3 square 9, 9 3 is 27. 27. Yes. So now let's give him the cube root. Okay. So I'll say result is equals to x to the power 1 by 3 within brackets for all obvious reasons. And I need this result object to be returned. So within this thing I'll use a return function and I'll put res into that, which means res will be given back to the user. That's it. There's no complicated stuff around it. If I just select all the lines and execute it, line number 9 to 12, it creates a function in my global environment. You can see that cube.root. A function has been created in my global environment. Let's online guys, any questions on this? I hope not. Right? Any questions? Anyone? Now let's do this thing a little bit maturely. So if I call a cube.root function here, let's say my input is 27, you get 3 as an answer, right? Or you may do this, like you can give a vector as an input. Do I have a vector? I think I have v1. So if I say cube.root v1, it will print the cube roots of all the numbers present there. So functions are always vectorized. Vectorized as in it can take vectors as an input. So let's do this function a little bit maturely. Now I need only numbers or numeric things as an input. I don't want any strings. If I pass string, it should display some appropriate error. So what I'll do is just look at the code. We have done if, right? We have done if in SAS as well. So if I say if class of x equal to or not equal to numeric or class of x not equal to integer. So real numbers can be represented as numeric or integer, right? So if class of x is not equal to numeric and not equal to integer, then print, let's say I'll more appropriately use a function called stop. Stop. I'll say stop. You can't enter strings. You can't enter non-numeric. Right? Else result. Clear? Now, if you can notice, I have made some changes in the function. Now, if you want it to be reflected properly, so all you have to do is select and rerun it. Every time you make change in a function, you have to rerun it. So always keep it in mind that if you're in any session, make sure that you are creating function in a separate file, separate .r file. It's always better, and it's always also advisable to maintain a separate .r file for each and every function. Let's say I've written a cube root function, I should store it in separate .r file called cube root. And every time I make a change while I crack on, I have to execute that first and then make use of that function. Pardon? Yeah, to save that function, to save the changes basically, to get that changes reflected. Now let's see cube root of 27. Oh, why is it showing an error? 27 is numeric, right?
Yeah.
Yes. Is there anything that I have missed over here? I hope not, right? I don't know why. Just a second, guys. I'm not able to figure out what happened here. Made here to this function has just replaced the if statement. Small minor change in the if statement, and the function is working fine. So if my input happens to be a number, then it gives the output. If I go for a non-numeric input, so I get an error, right?
But it should, as per the logic, it should have worked. Right?
It should have worked. I don't know why. I really don't know why it doesn't work. There was no flaw in the logic, and there was no error as well. Like syntax error was also not there.
Let's try to rewrite it maybe something the same way it was earlier.
Okay, we'll think about it. Let's crack on. Afterwards, we can think about that. What happened wrong in that previous statements? Pardon?
It's all about the logic that
The logic is all fine, right?
Yeah, that's the last part.
Let's say, I think there must be something happening over here with class of x. So I'll have to check for it. Class of x is numeric, fine.
Yeah.
So if I say class of x not equal to numeric, it is false, right?
Yeah.
Class of x is also not equal to integer. Oh. So that's where the thing.
That's why it was not.
Okay. Fine. Anyways, yeah. The OR condition was getting satisfied, so it has to be an AND operator over here.
Yeah. Yes.
So that's how it would have.
Either we can write it like class X is equal to alphabet or a string.
That would have worked. That would have worked. But anyways, you got the thing behind this, right? That's yeah. That's enough. That's enough. Yeah, is.numeric can also be used like you suggest, but the only mistake that we had done in the last case was use of an AND character here. So if I had used and I would have said not equal to numeric and not equal to integer, then the code would have worked. But anyways, I hope you got the main motive behind creating a function. So you should be able to take the inputs and give the appropriate outputs. So that's what is mandatory. Second example I just want to give you. What if, what if we have multiple inputs and outputs? Let's first see multiple inputs. Now I really don't have to discuss multiple inputs because firstly it depends on logic. Second, all the functions are vectorized. As in, if you are passing on a vector, the function will work seamlessly with a vector. So it's obvious that you can pass multiple values as input. So I need not discuss this. Problem is, how do I handle multiple outputs? So here where the problem comes in. So if let's say a function, I'll call this as maths, for example, I'm creating a function called maths. So keyword is function. So my motive is take two numbers as input and just display multiple outputs. So if I take two numbers, I'll first display x underscore square, in which I'll be calculating x raised to the power 2 and y underscore square. Just giving a trivial example to handle multiple outputs. X cube now let's say you're finding out squares and cubes of two numbers, that's it, plain. Now problem is you have to return all the four things. Do we have to write four return statements? Let's see what if we have to write four return statements. So my first thing is sq. I love copy pasting stuff. Now let us run this because we have written four return statements and see what happens with maths. So if I take, let's take smaller numbers, 2 and 3, I have written only one output. So four return statements is a bad idea. I can't write four return statements. What should I do? How should I handle it? Create a vector. Why do we have to create a vector? Return the vector. Good thinking actually. Good thinking. So if I have to return, see, whatever you're returning, whatever you're doing is an object. So if you are trying to return multiple things, you should think about an object which can store multiple things, right? It can be a vector, it can be a list. You have two options to go for, right? So what we'll do is we'll create a vector of result and return the vector itself, right? So I'll say result is equal to C, all these things. Right? And then return result. Now let's see the output. So re-execute this function, clear console and run this. Now we have a proper output, right? So understood why no multiple return statement can be used, but yes, we can use a vector instead, right? Clear with this? Okay. Did we discuss list, by the way? No, right? Okay, no worries, no worries. But online people, any questions on this? Any questions regarding this? Sanat, yes, we can do that in R as well, but R doesn't believe in human intervention, and also we never have discussed any kind of user input functions like we have raw input of Python. So you can always have scan function, like all those who know Python, you can use scan function in R and you can get your things done. And let us improvise this again. Let's improvise this a bit more. So you have a concept of named vectors. Named vectors. This is normal. This is your regular vector. If you have certain numbers or certain strings, this is just like your regular vector. The only difference is each and every position can be named. So please look at it. So if I say n1, if I call this as an n1, I have something called a vector which looks like this. I'm just creating arbitrary names for those positions, and corresponding to each position I have some information there. Now you see the difference between n1 and n2. So both contain the same kind of data. Both n1 and n2 contain 1, 2, 3, 4 and 5. The only difference is that the position of n2, all the positions of n2 are named. There is a name associated with each and every position. But both are vectors. Both are the same numerical vectors what we have known till now. So n1, let's say third element or second element, third element can be accessed by square brackets. N2, third element can also be accessed by the same square brackets, but you'll have some additional information here. Advantage with N2, you can also do this. You can write in the position name, you'll get the corresponding data value. I hope this is clear to you online guys. I hope this is clear to everyone. So we'll use the same concept of named vector in this result set. So I'll simply say x underscore square is equals to this. That's it. Now again, let's rerun this function, entire one. And if I print this, look at the results now. If I call this function, the results are being displayed in a more mature format, right? Any questions till here? Because we'll be finishing these functions on one last note. Creating a function which will calculate a few numerical attributes of my columns. So let's try to recreate the univariate function of SAS. So I'm just trying to design a function to calculate univariate analysis or univariate statistics for a numerical variable. I'll be finding out min, max, mean, median, variance and standard deviation. The ones you are seeing on the screen are the functions which help you to do so. Right? So help me out. What should be the first opening line? How should I start it? Name of the function, yes. So I'll call it as univariate, for instance. Function. Yes. One argument and then begin with curly braces. Now, Same thing what we have done, check. So if class of X equal to numeric, or class of X equal to integer, then do something, do this function. So I have to do nothing, just take this, copy it here and put X everywhere. That should find out min, median, mode, standard deviation and stuff. So one thing which goes in is na.rm is equals to true. In case my data has NAs, it just gets omitted. Now, of course, for better results, I will store this in result dataset. So I have min, max, mean, median, variance, standard deviation. Standard deviation, yes. So whatever I have calculated, I'll just put it in variables. So min is equals to this, max is equals to this, right? Again, you can even more improvise it by giving names. Say minimum is equals to min, maximum is equals to max, mean, midpoint is median, variance, right? And finally return result. That's it. So if class is numeric or integer, then perform these operations and return result, else stop. I've learned a trick. You give out orders to someone and just add please. So you can remove all your frustrations in that first part of the sentence. Last part you can just satisfy the listener by your please. Okay. So I was like saying, get lost, please. Kindly use N2 for input. Okay, I would do that. So what we'll do is, let's create quickly two vectors. One, we'll use N2. N2 is also a numerical vector. And let's create one sample vector. Let's take some 20 numbers or 32 numbers. And, maybe
over there you need to write
pardon?
standard deviation you have written over one extra d. If you are taking it.
Oh, I'm so sorry. Yes. Yes. So univariate on let's say alphabets is an error. Univariate on N2. Can I find function result? Oh, I'm so sorry. Result is equals to C. What was I thinking? So univariate N2. N2 happens to be a numerical vector. So we have the results here. Obviously, the lowest number is 1, maximum is 6. Mean would be somewhere here, 3.5. Midpoint is also 3.5. The median. Because this is uniformly distributed data, all the three are equal, arithmetic mean, midpoint and variance. You don't find it in real terms. If you find it, then it's almost equivalent to spotting an unicorn. Standard deviation, how much it is inclined from your midpoint. That's it. We can apply that to the thing N1 as well. N3, I guess, right? Some random numbers. So univariate N3. So if you are given with a random data, let's say if this N3 is representing total sales from our stores data set, I can find some numeric metrics out of it. Now we will be doing this function again in your BA class with few more metrics, furthermore metrics. Yeah. Now, if you have understood this, I have a question. I have a small problem here, not question. I have a small issue here. I hope these things are clear. We can proceed on, right? Okay. And there is a small issue. How do I apply this function? How do I use this function on my stores data set? This is my stores data set. Okay, first things first, what I'll do is from my stores data set, stores numerical, this is a subset that I'm going to create. I'll create this manually, by just identifying all the non-numeric columns and just removing them. So I'll keep only the numeric columns from the stores. So first 4 columns are characters, so non-numeric. I'll just discard them, and 5 to store segment is 15. So 5 to 15 I'll consider for numerical analysis. So I'll say stores subset 5 to 15. I hope we all have done this and remembered this. Okay. So I have 11 variables now. So now this function can very well work on this data set, right? Now here I have a small problem. Previous case when we used univariate for N3, N1, N2, we had only one vectors. We were going one vector at a time. We're going one vector at a time, right? But we have now here 11 vectors to apply that function on. We have to go for these 11 vectors at one instance. That is what is a small problem here. No, we can't do that. Why do you have to define a new vector with all the vectors? Because you already have column names, right? You already have it in the data frame, right? See, why I said 11 different vectors is because I have 11 columns in this thing, and for each and every column I have to find out some summary statistics for each and every column. So 11 times I have to rerun the statement. So ring any bell? What should we use here? Loops? Loops, right? Do we or do we not have to use loops? Yes? Online guys, what do you say? Should we go for loops? Can't we?
Can't we use univariate and then combine it into?
No? How can you use that? If you're combining these things into a vector, then it will form a huge vector containing 32 into 11 elements. It's not possible, right? It's not feasible. So online guys, do you agree upon using loops? Okay, I repeat my question. Online guys, if you are awake, do you agree on using loops? Really? Wow. Reply fast, please. I want quick replies. Okay. I thought I was the only sarcastic person in this room. Yeah. Okay. Okay. Oh yeah, she is from the same place where I'm from, right? So the effect stays. Yes. Yes, yes, yes. Okay. Yeah. True. No, actually, it's a fact. If you may know that. Yeah. All right. So let's look at how do we make use of loops. Loops usually in any language, there are of two types. One in which you know the limits, and in second in which there are no limits but set of statement repeat on certain conditions. I mean, these are not the technical terms for it, but I'm just for understanding, I'm just writing that. Loops which have limits. So usually if I have to repeat something within a range, repeat statements in a certain range, I'll go for a loop which can do that. So usually in any language, a for loop will do this. So if you know that you have to repeat from 1 to 10 or 20 to 40, you know the upper and lower count, or like 1 to number of rows in a table, you can use for loops for that. And second, if you don't know the limits and it has to go on a condition, like you begin with I is equals to 0, you begin with a variable is equal from 0, you keep on incrementing the variables by 10, and you wish to repeat a loop till v reaches 1000. So I repeat, I'll begin with 0, I'll keep on incrementing that particular counter by 10, and I have to repeat a loop till it reaches 1000. This is a conditional loop. For this we'll be going for while loop. There is a small difference between the 1000, the limit over here and the limit over here, right? Getting my point? This is just an example that I'm giving, like, or let's say repeat a loop till v. So you're just dividing v by 10 and repeat the loop till v is 0. For those conditions, we have to go for a while loop, right? So this is a general theory which exists in every language. Even while and for are the two valid functions present in R, which I will happily ignore it. Not just me, R advises you not to use loops. Loops are not at all required in R until unless it's a can-but situation. If you are programmer enough to use loops, you can use loops, but usually avoid loops. Even in SAS, we have never seen this concept of for loop, right? We have not seen it because statistical languages don't believe on loops. The only reason why R gave you is out of courtesy, because it knew that programmers will be working on this. Yeah, seriously. So that's why they have given these loops. Or else R advises you not to use loops. It has given certain alternatives for you. Some of which we have already seen in our day-to-day life with R, like accessing an element from a vector, or applying conditions on a vector, or on a data frame. We have done the entire data manipulation, but we have never used a loop. If it had been Java or some other language, even in Python, you are bound to use a loop. Python uses different packages. It's a different story altogether. Python uses something called pandas, which is just, it has copied the R code over there. So the square brackets is a by default loop, a loop which is faster than your for loop. So R advises you not to use any kind of loops. Now, here is the question. With the limited knowledge that I have on loops, I clearly know that if I have to apply this univariate function to my stores dataset, I have to use loop, without which I am not going anywhere. So I have to loop from 1 to number of rows and do it. So, and now suddenly I say that you should not be using loops. So what should we do? So for this we have a certain list of functions, not packages, not packages every time, right? We can limit to functions as well. So alternatives to loops is the apply family of functions. So you have certain functions which begin with this word apply. So instead of going for a for loop, we will go for apply functions. Let's see how it is done. Let's try to understand what an apply function does. Firstly, it takes the data. It takes the data. It takes a vector or matrix or a data frame as input. That's my first step. I can pass on a vector, matrix, or a data frame as an input. It asks for margin. Margins as in row wise or column wise or both. It will ask you what are the margins. Where do you want to apply a function on? Do you want to apply a function on your rows or onto your columns or both rows and columns? Where do you want to apply your function? And third is the name of the function. The name of the function that I wish to apply. Isn't this slightly addressing my previous problem, or is it the problem that I'm facing now? I have an univariate function which works well on a vector, but it fails to do anything on a group of vectors, right? Now, apply function looks like a beacon of hope, silver lining in the cloud, because I'm able to pass a data frame, check, excellent. I'll be able to pass a data frame. Second, it asks for margin. So here I need column wise. So I can supply some input saying that please do it column wise. And third, name of the function which I wish to apply. Right? Now, please pay attention to the syntax of apply function. What I'm trying to do here is apply univariate function to the columns of the table. That is stores num. stores numerical. So look at it, apply. Stores numerical, it's my data frame, it's an input. Now it is asking for margin, rows, columns, or both rows and columns. Please pay attention here. If it is row wise, then my input is 1. So 1 for row wise, 2 column wise, and 3 for rows and columns. For both rows and columns. Combination of 1, 2 for both rows and columns. So here what should be my margin? Columns, right? The margin should be equal to 2 and my function name is univariate. Please remember, and also please pay attention here, I'm not using a function call over here. I'm just using the function name, univariate. So I'll call it fun for function. Function is equals to univariate. Let's do this. Let's store it in a data set. I will call this as, let's say, univ underscore results. And please look at this. So this function got applied to each and every column and you have corresponding results for each and every column. You never had to do anything. You got the results straightforward. Any questions on this online, guys?
So basically we don't have any loops. Like we have loops, but we don't we don't require it.
We don't require loops, right?
Simply use a right now.
So here is the code for this. Saurav, is there any question that you wish to ask? Acha, I mentioned columns in the margin argument. Look at the margin argument there in between, the center one. That's where I mentioned columns. So if I had mentioned 1, it would have been row wise, 2 column wise, and C 1, 2 for both rows and columns. Can we see the code for apply function? But first 4 are alphabets. So yes, Saurav, if you can remember, if you just go back, what I had done is I had subsetted the stores data set here in line number 116. The first 4 are textual data, so I had subsets. When do we use C1, 2? 1, 2 means row wise and column wise. In other words, we are looking for each and every cell, right? That can be better used, let's say when you're calculating cube, when you're trying to square or when you're trying to cube each and every number, like we designed a function called cube root. If I just want to apply the cube root to each and every row, each and everything of that particular data frame, so I can say margin is equals to C1, 2, and the function name is cube.root. So, oh my god. So you can see each and every element has been cube rooted, right?
So likewise, as we do write as an axis, like x and y. X denote the rows and y denote the columns, right?
Okay.
So can we write earlier in the first one we wrote margin equals to 2, right? So can we write C 0, comma 2 like that?
What for?
For margin, as we have written C 1, comma 2 for rows and columns.
No, you can't write like that. That won't be a valid input. The allowed numbers, the accepted numbers are 1, 2 and C 1, comma 2. Yeah.
Is it possible we don't need to create a subset of that vector?
See, going by the logic, you have to.
Okay.
Because you have certain univariate analysis for a numeric variable, certain univariate analysis for character variable. Yes, the function can be improvised. In that case, you don't have to go for separate things.
I'm just asking that if we have something like large data, we have numerical data also.
See, for instance, if you look at this output from psych package, you remember this, right? So without having to create a subset, psych package is calculating everything for each and every data type, right? So they have written this function in such a way that they are picking up those objects and applying those functions on that. Whatever is necessary, wherever is necessary. The reason why I have stars here is they are factors. Apart from that, there is no other explanation why there are stars over there. Amit, code to the apply function can't be seen here. You can download the R binaries or base binaries. You can see the code of the R apply function over there. Now, getting back to the definition of apply function, it takes vector matrix data frame as an input, asks for margin and the name of function I wish to apply. So my fourth point here is, if data frame or matrix is input, or let's put it like this, if 2D data structure is input, output is also in 2 dimensions. And okay, so this is all about my output from apply function. And also, despite the fact that it can take vectors as an input, the reason why I don't want to go for it is because apply is specially designed for a 2-dimensional data structure, the rows and columns thing. Now coming to something called L apply and S apply. L apply and S apply. While we were discussing data structures, we have done vectors, which is 1-dimensional, and we have seen data frames which are 2-dimensional, heterogeneous. There was something called list. List is heterogeneous and that can hold multiple data types and multiple info in 3 dimensions. That is list. So list can hold multiple data types, which means list is heterogeneous. List is heterogeneous data structure, but the main significant bit here is list is a container for other objects. Irrespective of the data types. List is a container for other objects. So in my global environment as of now, I have variables or simple objects. I have vectors. I even have a matrix here. This univariate result is a matrix actually. If you can see that on my screen. I have a matrix, I have a data frame and so on. Right? Let's try to combine few of the variables, vectors and data frames into a single unit. Right? So I have a function called list. Just like your C function, which can arbitrarily take any input. It arbitrarily takes any input and combines that input into a single unit called vector. This is what C function was doing, right? I have list function which takes n objects, arbitrary objects as input and combines them as a single unit called list. So let's take an object called, let's say C1. I have something called C1. I have a logical variable L1. I have vectors N1. I also have another vector V1, and I'll quickly import a table called scores. What does this sign stand for?
Location.
Which location?
Stored.
Yes, my documents, right. So I have scores. Okay. I'll call it as my list 1. So I simply put on some objects and combine them into a list. If I execute the statement and print the contents of my list 1, so look at it. So what do you infer from this my list 1? It contains positions. I have 5 elements that I have passed. So 5 positions got created, and each and every position has a particular value over there. First is a string called R class, second is a logical element, third is a numerical vector, fourth is another numerical vector, and fifth is a data frame. Right? So list can be a container for other objects. This is what it means. The purpose of creating list, Amit, is to have a consolidated storage of all your objects. Let's say you need these 5 objects as a part of your some task. You can keep them in a list and access them. Accessing them by keeping it in a list becomes very easier rather than keeping them dangling in the global environment. It gives you more orderliness to your data objects. That's the purpose of list. And R extensively uses list in your function return types. In our previous function, we have happily used a vector because we know that our output A is homogeneous. The univariate statistics that we are returning is all homogeneous, right? What if we had a situation where you had to return multiple objects which are from multiple data types? We couldn't have used a vector. So those are the cases when lists will be used. So keep it as a thumb rule. You won't encounter list anywhere except, of course, when you're calling a function. You're doing your linear regression, you're using your LM function or GLM function, the output is a list. You're using time series, your output is a list. You're using your fit function, your output is a list. Everything that you do, every advanced function that you're using in R will give you list as an output. Clear with that? So use cases, many use cases you'll come across eventually in your BA class. Amit, wait, I have not come there. I'll come there eventually. Please wait for me to complete. Now, if you have created list, just remember our data structures classes. First step was creation. Second step is how do we index them, right? Now, if you look at the output of mylist1, you can see that these things are printed using double square brackets here. So we have to make use of those double square brackets because they are the ones which are indicating the positions. So if I say mylist1 double square brackets 1, this is just extracting the first element out of that list. Or say mylist2 mylist1 double square bracket 4 or something. The fourth element has been extracted. So if I use double square brackets for extraction, I can extract one element at a time. Use a single square bracket. What does a single square bracket do here? I will kill these people actually. So if I'll be using a single square bracket, I can extract a group of elements. From the list. In other words, a sublist out of a main list, right? So let's do one example. If I say my list 1 double square brackets, single square brackets combination of 1, 2, or let's say some randomly 3 and 5. So it is printing the third thing here, which is N1, and fifth element, that is the table, from my list 1 object. And if you notice it carefully, the result is a list. That's why I said if I'm using a single square bracket, I can extract multiple elements as a sublist, right? It's like slicing your list, extracting a part out of it. Any questions?
When you want to access the data inside that
second list,
yes,
then you have to subset it again. Store it in an object, subset it now. Let's say you have subsetted the 5 element list into 2 elements, 1 vector and 1 data frame. You want to get data out of data frame, you have to subset this list now. Any questions so far? So, okay, the double square brackets will extract the exact element present in that position. So if I have list of 5 elements, a double square bracket will extract any given position. So that object which is present in that position can be anything. It can be a simple vector, it can be a data frame and all. It is extracted as it is. But if I'm using a single square bracket, I'm extracting a sublist out of a bigger list. I'm just breaking the list and getting the smaller part out of it. Select a column in object. Which object, Amit? Okay, let's say my list's 5th element is a data frame, right? In this, let's say we need the first column of this data frame. Now, you can do it this way. You can save this as a data frame. So I'll call it as df underscore from list, which means this data frame is coming from the list. And to select first column, we all know it, how to do that, comma 1, right? This gives me the first column of the data frame. Clear, Amit? Is this clear to everyone? Now these two lines here, please pay attention. Parisha, you can't use the double square brackets for, you can't use multiple elements in double square brackets. Either it can give you an error or it can give you a warning or incorrect output. Come here. Come on. So yes, these two statements here can be combined to one single statement. Please pay attention. Line number 177. Till here, my list 1 double square brackets 5. It is extracting the data frame. So this here will contain the data frame. If it immediately follows with some further subsetting, depending on which data structure is present in the fifth element. We all know that fifth contains the table, so I can simply use this here, comma 1, to extract the first column of the data frame which is present as a fifth element in your list. Any questions here? I hope you guys understood this. Online people? What happened? Okay. One final thing about lists, then we can go for a break. Looks like everyone is feeling sleepy out here. Acha, coming to Amit's previous question, is the list actually storing objects or is the list actually storing the reference to those objects? So thing is, list is storing the objects as it is. So if, let's say, I have created my list 1 and I'm creating this data frame called scores. I'll do that right away. I'm removing scores. So scores is gone. But still my list 1 is intact. My list 1 still contains the information from stores 1. So no matter your original data is gone, the things remain in list because it is not a reference but a copy of your data which is getting stored. I hope you understood that now, Amit. Now, one last thing about lists. I'll just copy the statement again. I hope you understood how to create a list. Now, just like your C function, we have seen how to create a named vector. Same wise, you can create a named list. So I'll simply use some arbitrary names. I'll call it title, for example, logical vector, numbers, data, right? And if I execute this and I'll call this my list 2, if I happen to execute the statement, okay, scores is not found because we have removed it, right? Okay, let us call it again. Okay, that's it. So my list 2 printed, but please notice the difference between the first one and this. So the double square brackets are gone now, right? Rather, you have something called dollar followed by the name that you had given there. Title, logical, vector, numbers, that arbitrary names that I have given, it got appeared over there. Now, despite the fact that there are no double square brackets, the double square brackets can be still used for named list. So my list 2, which is a named list, if I'm using double square brackets and I'm saying double square brackets 5, yes, I'm able to extract the data frame out of it. Please notice that. Right? But why do you want to do this? Because it's a named list, you have an advantage of using the name. Please look at line number 188. As soon as I put a dollar sign, the names of the elements have appeared, just like your data frame columns. So I can simply select the data and just print it. I'm just referring the things by its name. Any questions? And dollar operator and double square brackets, they are one and the same when it comes to its principles, that it can extract only one element at a time. Any questions?
So
Yes.
dollar is used for only that data is a string or character, right? So,
Nothing like that.
so
How did we extract column names? So if I have stores data sets, I use the dollar sign and I'm able to access each and every columns, right? It's just an operator. There's no logic behind it. So likewise, my list 2 is a list. As soon as I put dollar, I get the element list. Yes. Look at the symbols here. I think this rectangle here might represent a simple object, and data is being represented by this small rectangle. So you have data referenced by the name. Any question online, guys? Good. Okay. Yeah, of course, that goes without saying. You can also access it using double square brackets followed by name in quotations. Right? Yeah. Okay, it's 3:32 now. We will come back at 3:45, shall we? Okay. So if I talk about variables or columns, till now we were broadly calling it as numbers, numerical or non-numerical. But statistically speaking, in terms of statistics, we have two terms for that. It's not numbers and non-numbers. Numbers and non-numbers are just for the language understanding. Statistics have two classifications for that. They call it continuous variable and categorical variables. So there are two types of variables that we can have in our data, continuous and categorical. So I'll give you examples. You will be able to figure out the differences between continuous and categorical. Categorical is such a variable which will divide your data into categories. So if I have gender, for instance, my data is divided into two parts. The entire data subset for males, the entire data subset for females. We have all done this, like we had done binning, store class, for example. We have done this kind of binning. Store class is dividing it into 4 categories based on certain criteria, right? So these are categorical variable. Continuous variable like income, sales, total cost or operating cost, name, ID. So these things are continuous variables. Again, like I said the other day, it's not necessary that a continuous variable has to be a string. It's not necessary that categorical has to be only strings. It can be numbers as well. And continuous can be strings, not just numbers. Now, based on these two, we'll have certain kind of analysis, which again, we will be seeing that with more details and with more patience in our first 2 BA classes. So we have certain kind of analysis on that, so analysis as a part of exploring past. So as a part of exploring your past, so you can do on these continuous and categorical. I have two kinds of activities that I can do. It's univariate analysis. We will be taking one single column and trying to do some analysis on that, or it can be multivariate to bivariate to multivariate, more than one. So bivariate as in two variables, multi as in more than one, right? So I'll just take bivariate for reference. We can figure it out for multiple variables. Now, same story here. So if I talk about univariate, so I have to divide them for both continuous and categorical. So it is almost like univariate continuous and univariate categorical. So what are some factors that we can go for univariate continuous, which you have already done? So min, max, median, mean, standard deviation, variance, what else? Skewness, kurtosis. These are certain statistical metrics that we can calculate on this, on continuous variable. Whereas on categorical variable, the only thing that we can do is frequency on proportions. These are the two activities that we can do on a continuous variable, on a categorical variable.
Probability or compared to what?
Pardon? Probability?
Probability.
So if you want to go for probability and all that stuff, you have to do it on continuous variables as well. That's not a statistical metrics, but it's a statistical calculation that we are, about to do. Now, when we have this univariate analysis done, there are also certain kind of visualization which holds true for one single variable, right? How can you see that? How can you see one variable? So if I consider univariate, the only visualization I can go for is distribution of data. And not just the visualization, but all the things that I'm calculating over here, both for continuous and categorical variables, I'm mostly looking for the distribution of my data. Min and max gives me the range, which is the distribution of your data. Variance gives me the variety of my data. It is also talking about distribution. Median, arithmetic mean. Median is the midpoint, arithmetic mean is the center point. It also talks about the distribution of my data. So, univariate analysis, distribution and visualization, there are certain graphs which you can go for. So for continuous variables, I can draw a histogram. I can very well draw a histogram. I can go for a whisker or box plot. Box plot will be representing the 5-number summary in a graph. That's a box plot. And of course, the kind regular thing that we can go for any kind of continuous variable, a scatter plot. Dots, simple dots. Yes, you have two axes and you have certain data you have taken on y-axis, and you are just plotting those dots based on its positions, a scatter plot. Frequency and proportions, I can't find any best graph other than a bar graph. And of course, a pie chart. Any questions on this? I know I'm going a little bit overview on all the things. I'm not going anything on details. It's not required. Now, it will be needed next week. Tomorrow you have a holiday. Lucky people. So, Yes, Sanat, line, point, everything comes under scatter plot. Just join those points, it becomes a line graph. So that's why I used a broader term called scatter plot. It all begins at scatter plot. Line is just a modification to your scatter plot. And if you're referring to a curve as a line, yes, it can also be done. But the starting point for any of those graphs is a scatter plot. Want to draw a curve, you have to go for a scatter plot first, right? Any questions? Okay. Even if you look at bivariate analysis here, taking two variables at a time, bivariate I can have, I'll use the word con for continuous. So I can have two continuous and two categorical variables. Continuous, categorical and categorical. Or you can have a situation where you have one continuous and the other categorical variable. Right? So what kind of metrics can you get within two continuous variables? Comparing to, no, you can't find out min max for two continuous variables. Any statistics people here in the class or online? Anyone from stats background? You better sit here. Just kidding. So I'll do one thing. The statistical metrics that we do for these three variables, I'll ignore it as of now, because I can't. I mean, like, if I name it and I can't discuss it, it's no point in that, right? So we'll do that in next Saturday. But as of now, I'll just want you to tell a few things. Just try to visualize that. Cat has a categorical variable. So I'll be telling few things. Just visualize that with examples. Let's say I'm taking, for example, sales. Okay, just a second. One second. So let's say on y-axis I'm taking sales, the total sales, whatever we have, and here I'm taking location. So this is a continuous and categorical variable that we are viewing. If I want to view it, which graph is more efficient for that?
Bar graph.
Bar graph or a column chart is more efficient in this case. Location, I have 4 locations here: Delhi, Mumbai, Chennai, Kolkata. So for all these 4 reasons, so I can draw a consolidated bar graph. So I'll find, let's say I have found out total sales from each of these locations. And I'm just drawing a bar chart out of it. Yeah? I know the drawing sucks, but still. Okay. Bar graph is fine. I can also go for a whisker plot, a box plot. For each and every location, what is the distribution of my total sales? So instead of these bars, I can still have, a whisker somewhat like this. So box corresponding to each location. So this is how a whisker looks like. Right? So this will be my median. So this can be done for each and every location. What else you can think of? What else you can think of? Any other graph, any other visualization that I can think of in continuous and categorical? I think that is it, right?
Pie chart.
Pie chart, how do we do that? Yes, of course we can do a pie chart. We can also have a pie chart, yes. So, okay, drawing straight lines was easy. So, imagine that this is a perfect circle. So you have 4 locations, yeah? And out of these 4 locations, you will be distributing your total sales, right? Yes. You can see which thing contributed more to your sales, which is almost similar to your bar graph as well. So I can safely write that if I have a continuous and categorical variable, I can go for a bar plot, I can go for a box, I can go for a pie chart. What if I have 2 categorical variables, location and store type? Is there any graph that I can go for? Okay, the answer is yes, bar plot, but bar plot not that direct, but it's called bar plot of the cross tabulation between those 2 categorical variables. So with one with respect to other, I will be finding out frequency. This is what is mostly meant by your cross tabulation. We'll anyway see that in your stats class, but this is the visualization that you can get for a 2 categorical variables. So if I have a bar plot, I can have the box and pie as well. In addition, that's okay. I'm so sorry. I can't have a box plot here for 2 categorical variables. I'm really sorry. I can have a bar plot and a pie of the cross tabulations. And cross tab is simply the frequency count of a particular categorical variable with respect to the other. Right? The reason why I'm telling you this is basically we'll be having few graphs to go for, and you must really know which scenario, which graph you can use for visualizations, which anyways you'll be eventually getting it in your remaining 10 BA classes. And coming to 2 continuous variables, the only graph that I can clearly think of is a scatter plot. It's the only thing which I can think of, a scatter plot. Clear? Now we'll spend the next 20 minutes in getting a scatter, bar, box and pie in R. That's it. Is there anything that you guys wish to ask for? Yeah. Any question?
Just asking what is that? We didn't do that in class.
Which one?
Graph project. We just have an overview of it.
Okay. So you didn't do it in SAS because you can't do it in SAS, base SAS.
Advanced do it.
You have to go for SAS Visual Analytics by paying 20 lakhs per annum as the license cost.
But in university edition, there is one.
You can draw. You have proc univariate, which gives you histograms. So histograms is one of the visualization that we can go for a continuous variable univariate analysis, right?
Like there is a task segment in university edition where we can plot a graph related to that. I tried to use that.
Okay, good book. Let's use R now. So this will be more of a story. I don't want any sleepy faces in the class, especially the class. Online people, they're anyways halfway through the sleep. I hope so. They're not. Okay. Good. Just totally proud of you guys. So our target is to go for graphs. What I will be doing is we will be learning about the base plots, also some of the functions from ggplot. I'll also be sharing a detailed material on ggplots. So whatever we learn in this class, we will try to implement that eventually in further avenues. So if you don't have ggplot, quickly install ggplot, the online guys. Now we'll begin with a generic plotting function called plot from base. What I'll do is I'll take a vector of 10 numbers, right? Some random vector I have taken. Or let's say we already have few vectors, like let's say n3 we have, right? So if I simply say plot n3 and run the statement here, it will generate a one level of scatter plot. This is almost equivalent to your Cartesian graph. So after 0 you have 1. So from at position 1 you have this number over here, which is 733. 733 is almost here, somewhere around here, between 650 and 800. So you have 733. That's your first point. Second point is 659. Yes? Second place, and so on. It goes till all the elements. Like we have number of elements in N3 is around 30. 30 elements, 30 or 32 elements are now represented as a part of this graph. So this is simply drawing the data points which is taken in y-axis. The y-axis contains data points. X-axis contains their positions or index. So this is your simple plot. Any questions? So y-axis is set as default. The vector that you are passing is set on y-axis by default, and x-axis will have its indexes. This is all about your plot function. Okay, now what we'll do is let's try to improvise this a bit. Please look at it. Plot n3, for instance, I'll go for certain options. So if I say xlab, so xlab will add a label for x-axis. Okay. xlab is labeled for x-axis, so I'll just say positions. This goes as label for my x-axis. I have ylab, a label for y-axis. The actual data. What error is being shown here? One second. Oh my God. Somebody stop this, please. Okay, finally. So sorry for that. Somehow the entire file got executed. So okay, here we go. Do we still have N3? No. We have the old ones. Okay. Again. I understood my blunder there. Yes. Yeah, there's an extra commas here. Okay. So X lab, Y lab for your labels there. So this is a little bit different from your previous graph. Also, I have certain options here. If I go for something called main, so this will add a title to your graph. For my first graph, that's a title. Now, apart from these, one of the most important arguments here, if you can just go to the plot function and see it, is this, the type argument. So, by default, the type is P. So, by default, it's P for points. So, you can also specify L for lines, or you can go for B, which is both points and lines in the type argument. So if I say type is equals to B, so here we go. Both lines and points on this. We also extend this example to one of the variables from our stores data set. We can do that. So if I can say stores dollar operating cost, for example. So if I plot it, so according to its indexes, I get the distribution of the operating cost. So let's say if I have a retail data which is extended which is represented through a timeline, I can very well see how is my operating cost going, which season it is more, which season it is less. That kind of information I can get it from this kind of a scatter plot. Yes? So this is basic distributions, nothing much. Here I want you to understand the syntax, that's it. I don't want you to understand or just think about the statistical application of it. I just want you to understand the syntax, how a certain plot is being done. Now look at it this way. I have taken a vector v1 and there is a vector called v2 here, which we have created by taking certain random elements there. So that's v2 which has been created. Now if I look at the very definition of plot function, it says that it is generic x and y plotting, right? Which means it's a if you consider this in a Cartesian system, one point will represent a dot from a corresponding point from the horizontal axis, the other with the vertical axis, the xy. So if you look at line number 25 here, I'm taking two vectors and I'm passing it on to two different axes. On y-axis, I'll be taking the data, vector v2. In x-axis, I'll be taking v1, which is basically numbers from 1 to 10. And both are of same size. Both are 10 elements each. Okay. I'll reduce one because, okay. Both are 10 elements each now, right? So if you look at this, the elements that are being passed on to x-axis is from another vector actually. And this here's some data points that I have passed on to y-axis. This represents your generic xy plotting. A little bit extension of this example can be taken when we draw such a plot for total sales and total cost, operating cost. So let's see it here. On y-axis I'm taking total sales. On x-axis I'm taking operating cost. So if I happen to plot this graph, okay. Sorry. So this is a graph that I end up with, right? Now, if I happen to draw a curve, an imaginary curve, this graph shows that the two variables are inversely proportional to each other. So with increase in operating cost, there will be a decrease in your total sales. So I am able to establish a relationship between two variables, and this is a bivariate scatter plot, right? Again, I said it's all about the syntax. Previous case we are passing on only one vector. In this case, I started passing x and y both. If I just want to go for multivariables. Now, what was the factor? What's a factor? A thing that represents a categorical variable, right? A data type which is built to represent a categorical variable. It has something called levels and all. Now look at this. Into my plot function, I am passing on total sales, not an issue. I'm also passing on a factorized version of your location, right? So this will basically, and internally, it will cross-tabulate between location and total sales. And by default, I don't have any control over this on plot function. So if I'm passing on one continuous variable and one categorical variable here, as you can notice, so a plot function will always give you a whisker plot. So I have not changed any syntax. The only thing that I have done is I have passed on one continuous variable on my y-axis and a categorical variable on x-axis. This is the only thing that I have done to the plot function. And this categorical variable I have passed it on as a vector, a factor. So this is what I end up with. This is by default, which is appearing from your plot function. I am not doing anything over it. And I hope you very well know how to interpret a whisker or a box plot. This below line here, this represents minimum point, minimum of all values. This represents my 25 percentile or first quadrant. The dark line over here is the median, not mean, median. This line here is the 75th percentile or third quadrant. And this is the max. Or a calculated max, not the direct max function from your max function. Now, there's also a concept called outliers. How do you calculate outliers and stuff, which again is a part of your stats. So a box plot is some visualization which can clearly give you outliers. So if below the max and below the min and above max, if you have any dots, they're considered to be outliers. And please remember, these 2 points here are not the straightforward max and mins. These things are known as upper cap and lower cap, which again we can discuss clearly when we're going for stats. How do you calculate upper and lower caps? Just for your information's sake, I'm telling this. So I hope there is no confusion around how did we get a box plot. This is something which is not in my control. Based on the inputs, I'm getting this graph as such. Any questions online, guys? Okay. Now let's see some examples from our ggplot. So ggplot is something which is created by RStudio. GG stands for Grammar of Graphics. It is aimed at giving a robust representation of your graphs. So it works on few principles. It works on layers. So your first layer is an empty canvas. If you remember those graph sheets which you used to have in our childhood, no? So you take those graph sheets, draw your own grid, draw the x and y axis, and then go for a graph which you need. This is what we used to, this is how we used to do it. So this is how ggplot works exactly. Take an empty canvas, draw the axis and grids, or grid points to be precise, and then final step, draw the graphs. And in the third point, the graphs that I'm talking about are denoted by a geometry function, which is a part of your ggplots. So things like if I want to draw a bar plot, I have a geometry function for it, which is geom for geometry underscore bar. I'll tell you these examples. Scatter plot with only points, it's geom underscore point. Line graph, geom underscore line, and so on. So your empty canvas begins here, where you will be passing on the vectors, which we did it in the plot function as it is. And the same step will do the second step as well. Draw an empty canvas. And third is specify the geometry. Let's do an example for the plot function, what we have done now. So we had plot in which I said x-axis is equals to stores $operating cost, and y-axis is equals to stores $total sales. This was our simple plot, right? Now let's do that with ggplot. I'll just call it as ggEX for ggplot example. So the function is ggplot from your ggplot2 package. But first things first here, because I'll be working with a data frame. So first things I have to specify the data frame name. So that is stores. Clear? Now, after I specify my data, I'll have to specify my aesthetics, the visual aesthetics, the visual representation, the x and y axis. That's aesthetics, which contains two arguments, x is equals to and y is equals to. So what's my x-axis? That's it. I'll put operating cost over here. Y is total sales. So thus we are creating a backdrop first, an empty canvas and the axis. So when I run the statement, line number 11, it will create some ggplot object. And if I happen to print this, just execute this object, ggEX, that will draw an empty canvas here with the grid lines. So step number 1 and 2 are done. Any questions online, guys? Can be quick. Let's close it up soon. Any question? Okay. Now, to this plot, I'll be adding layers, right? So please notice the syntax that I'm doing here, right? So to my original object, using the plus sign, add an original, add a geometry. So I'll be going for a scatter plot. Scatter plot is gem underscore point. So gem underscore point, right? So I'll execute this statement here. Now if I run this, yes, I have a scatter plot over here, which is a little bit more clear and more robust than your regular plot function, the base plot function. Any questions? On a scale of 1 to 10, this is cool, right? For a free software. For a free statistical tool, this is cool. No? Can 11 and 13 be put in one line? Okay. 11 and 13. Okay. So if you want to write this entire thing in one single line, needless to say, just use this. So ggEX is equals to ggplot code plus gem underscore point. Any layer you want to add, just keep on adding that particular function over there. That's it. Now this is cool, right? On a scale of 1 to 10, how much cool is this? How cool is this? 9.5. Sarcasm. Sarcasm, what I call it. It's hot. Amit, so far you have been the most brilliant guy here around. Thanks for that. And this is no sarcasm. But let's try to see something which is more cool than this, cooler than this. I'm like, yeah. So there is something which is more cooler than this, you know. I have a package called Plotly. Right? You can install this package. So ggEX is a ggplot object. Class, I think it will give a list. So ggEX is a ggplot object, right? So there is a function in Plotly called ggplotly. So if you notice it, this is from Plotly package. So to this ggplotly function, if you're passing any ggplot object like ggEX, it will also give you a graph. Same one, which is, right? So what's so cool in this? If it is giving the same graph, then what is so cool in this graph? It's the same like before, right? Interactiveness. So you hover your mouse, you'll get the interactiveness out of this. And now you can export this graph as it is using R Markdown. So simply create an R Markdown from here. We call it as graph demo. So our setup in this, I will quickly read the stores data set. And I'll just remove this nonsense. I told you I can add any codes here. I will be adding these codes. So within this, and our syntax can go in, right? So I'll save it. Graph sample. Let's create a new folder for you guys. Do I have one? Yeah, I do have one. Jan batch, graph sample, and export it to HTML. Oh, okay. So require ggplot, require plotly. When your friends keep chatting on Facebook and you can't see that, and all you get is notifications. So you can see I'm able to extract or export this into your HTML file, the interactive graph, right? Or if you just want to see it from the browser, you have your Jan batch. Simply open it with your browser, you can do that. So here we go. This interactiveness stays, right? So this is how we do it. Let's quickly do a few more examples of these scatter plots in ggplot2. Okay.
Does this interactiveness always with all the type of like this code we do?
No, you have to export it only as a HTML, of course. Like it will be creating some JavaScript, so you can see it over there. If you are exporting that to a PDF, it will be a static graph. PDF or Word document, it will be a static graph always.
Like we can do something like the positions, well, get those points marked.
Get which
Without
points?
without getting going through a mouse. Without going through a mouse to track
Achha, creating labels, right? Yes, it can be done. You have your labels functions. That's what I said. Like, I'll be giving an entire reference to your ggplots, how you can create labels and all. So all this 100 or 200 points, whatever exists, everything will be labeled automatically without the mouse hovers. Yes, it can also be done. But just think about it. Is it a beautiful graph if you do that way? It's not, right? It will be quite zigzag. Yes, you can do with a labels argument. I will be giving that in your documentation. Okay. One more example we'll do. We'll be taking some inbuilt data set called pressure. It's a graph between your temperature, a relationship between your temperature and pressure. Normally speaking, it's inversely proportional, right? So let's first draw a normal plot and just see that. So it has two columns there. So on my y-axis, I'll put temperature, which is the dependent variable actually. So and on x-axis, I have pressure. So I'm sorry, I did the reverse. I'm so sorry.
It's directly proportional.
Directly proportional, yes. With increasing temperature, pressure also increases. Yes. So if I give an option called type is equals to B. Oh, I'm so sorry. Type is equals to B with quotations. This would also be doing the lines as well, right? Now, how do you get this done using ggplot? So you will be helping me out with this. So I'll start with let's say PT graph, pt underscore graph. Yeah. How do I start with? ggplot, yes. Data is equals to pressure. And aesthetics, AES. X I have taken temperature.
And Y equals to pressure.
Yes. Now to the same thing, I'll go for a plus sign and add geom underscore point. Yes. Plus geom underscore line. That's it. Right? So if I just go for ggplotly function for pt underscore graph, it gives me this one with interactiveness. Yes. So I hope you got the essence of ggplot. Like just keep on adding the layers. That's it. Whenever you encounter any kind of graphs as a part of your BA, you should be able to do this. I hope so. I'm more positive on it. I'm counting on you guys.
This is the better part as compared to SAS.
All right. Let's quickly get into bar graphs, shall we?
Yeah.
Okay. So again, see. Okay. So here we go. What I'll do is I'll take the stores data set. Let's try to do some pivots in brief. Some of your pivot operations, if you guys know what pivot tables are, of course you would be knowing it. So simple pivot will do one thing. We'll take locations, and location wise, let's find out the sum of total sales. Right? How do get this done in R? How do we get this table in R? Which thing should I use? How to get this done in SQL or in SAS? Which, yes, group by. You have to go for group by, right? Okay. So let's do that. So stores, I have stores table. I have location. I should find out sum of total sales, right? na.rm is equals to true. Now riddle me this. I should begin with stores and group it by location, right? So what package should I use for this? Of course, dplyr. Right? Now go for dplyr. I have group underscore by a function in dplyr. So just put it in a temporary variable, group underscore by stores location. And finally I have result 1, I'll call this result 1 is equals to summarize. I hope we have done this in the last class, right? Summarize what? Summarize T and find out sum of total sales. And I'll just give it a name. The sum of total sales is equals to sum total sales. That's it. So if I view this result, it is similar to what we have got in Excel, right? Next step here is a chart that I insert in pivots, a simple bar chart, right here. Clear with this? Now, how should I do that in R now? Of course, ggplots, right? Please tell me this. I hope online guys, you guys are following that. So ggplot. Which data set you should be considering now? Stores, right? Stores or results? Stores, of course. We're working with stores data set, right? Why would we go for results, right? So pivot is based, when this graph is based on this table, right? And this table is result, isn't it? So result 1. Result 1 is my input table. AES or aesthetics, x-axis, what I have taken here, what is the graph in x-axis here? Location. Fantastic. Right? Now, here comes the tricky part. I'll just put it in an object, I'll call it as bar 1. So, straightforward, if I want to add a bar graph, it has to be geom underscore bar. Right? End of the story. There is a small thing that you have to remember as a part of syntax. There is no logic behind it, but this is just a syntax. You have to put something called stat is equals to within quotes identity. Yeah, stat is equals to identity. This is the only part of the syntax which you have to put. Just for your information sake, by default, stat is set to count. And this holds true for frequency counts across tabulations. This is by default. But here in our example, this is not a frequency table. It's a normal bar chart which is showing some values. So that's why I have to use something called stat is equals to identity. So had I not used this, one second, what happens if you don't use this? Bar 1 will be an error. Stat count must not be used because by default it is set to count. So stat count should not be used. So I have to set it to stat is equals to identity. Right? Once I am done with this, if I print bar 1, I have a graph. Same graph which has Excel has generated.
Okay, here stat is automatically taking as a count.
Count, yes. If we are not providing it as identity, we have to give it as identity to get a proper graph. Because we are not going for frequencies. Count is frequency count, right? Count and count percent. Frequency count and proportions. We're not doing proportions here, right? That's why you have to use stat is equals to identity. Now you have few more options. Yes, it's only for bar graph, Ayush. To geom underscore bar, you have few more options. Of course, why not? You can say fill is equals to, within quotes, blue, any color. Yes, just keep changing that. Again, further options on ggplot. I have the files that I'll be sending you today. One of the files will be ggplot2 cheat sheet. Cheats, yes. So in that you'll find something, how to get rid of your backgrounds, how do you change colors, how do you get colors in the first place, everything will be mentioned over there. So this, if I keep saying that in the class, it becomes more hectic. You can't remember it as well. There's no explanation needed for that. Only thing is you have to see which function or which feature where you can use it. So it's totally subjective. It depends on your situation, what you're doing, right? So that's why I'll be giving you it. I request you to try out the same exercises with different options. I'll be sharing you this graph stuff file as well, right? Now, any questions on this online, people? Now, quickly going by this graph, let's create one more pivot. And this time I'll be taking location and store type and sum of total sales, right? So if you try to insert a graph, okay, store type, let us take it as columns, right? So if I insert a pivot chart, I'll be getting this, right? Now how do we get this done in R? So to do multivariate, so multivariate bar graphs, we'll use an option called fill or filling and faceting. We'll be using these two options of filling and faceting. Please pay attention. So previous set of statements that I'll copy as it is. Mostly we will be using that. So I'll call this T2 for example, and this becomes result 2. Please pay attention. This was grouping by location and store type, right? So I'll begin first grouping criteria is location, second is store type. I hope everyone on the online also are following this. Result 2 is summarized T2. Sum of total sales is equals to sum total sales and RM is equals to true. This is all fine. So if I happen to run these two statements here, result 2 is yes, 12 observations. I mean, like if you can, R will be showing you by default the long format. Excel is generous enough to show you a wide format. Same data, different representations. That's it. Nothing much difference in that. Now, how do I get this graph done using bar plot now? So I'll call this bar 2 instant now. So I said you will be using an option called filling and faceting. Here in this case particularly, we'll be using the option filling. Please pay attention. The entire graph is fine, perfect. There's no change, but somehow or the other you have to accommodate a third variable now. I have X and I have Y, which is going for two variables. I have one more variable left, which I have to accommodate it somewhere, somehow. So in that case, I'll be using this option called fill. Within your ggplot function, aesthetics, I'll say fill is equals to store type. So this is my fill. So please look at the graph now. Oh, 1 second. The syntax, I think bar 1 or bar 2 was just getting mixed up. So once I removed bar 2 and I created it again, so problem is solved. So this graph that you're getting is something what we call it as stacked bar plot, one upon the other, right? Now let's do this bar 2 underscore 1. Same thing, no change, but I need a graph which I am getting into in Excel, right? So this here, it's called dodged bar plot. So the only change I have to make in bar 2 underscore 1 to get that kind of a graph is to change its position or bar position. There is an option called position here. Within quotes, I'll call it as dodge. So same graph. Okay, bar 2 underscore 1. I'm so sorry. So this is the same output that we are getting from Excel. Of course, extending this, you can extend this by going for ggplotly. That's it. So what small mistake happened before was bar 2, maybe it was referring to some other object. Once I just removed it, everything was normal.
But here we are not using filling, right?
We are
not using the filling.
We are using the filling here. Fill is equals to store type. Okay, I have also removed this fill here at geom bar. But anyways, fill I am just fetching it from the main function, right? Any questions or any confusion there, online guys? Any questions? Okay, I'll talk about Faceit now. If we are done with this, right? Now, talking about Faceits, just look at this graph again. What if I'm changing? I'm removing the store type from columns or legend, and I'm getting it over here, just below the location. Look at the change in the graph. I have 4 locations, and within those 4 locations I have 3 types. So my entire graph has been divided into 4 parts based on your 4 locations, and each part will have the corresponding total sales within each category. So let's try to implement that using Faceits. So again, my result set, is it going to change? I don't think so. My result set will not change. I'll simply copy this bar 2 graphs here, and I'll just call this as bar 3. So I think I have this function faceit underscore grid. So layout panels for a grid, as in it will try to divide my ggplot graph into various grids, as in rows and columns. So please look at it. I'll be removing this fill option here from the original ggplot function. So it's bar 3 ggplot result to aesthetics x is equals to location, y is equals to sum of total sales, geom bar stat is equals to identity. Now in next step, I'll put up the faceit bar 3 plus faceit underscore grid. Now this is a little bit tricky. I'll be using something called a formula in R. So formula is something which involves a tilde operator. I'll be using a small formula which something goes like this: row side tilde column side. So if you want some particular variable to be dividing your graph into columns, let's say in our case we are taking location, and based on location my graph is being split column wise or horizontally. I am so sorry, graph is getting split vertically column wise, right? So in that case I should be writing dot as in none, followed by tilde, followed by location. This means that my graph has been divided based on location column wise, right? So let's try. So I'll say faceit grids. By default in x-axis I'll take store type. So in faceit grid I'll be taking dot as in none for the rows part, tilde location. Look at this. This is almost similar to this graph here. I have 4 divisions: Chennai, Delhi, Kolkata and Mumbai. Same kind of 4 divisions occurred here. My bar graph got divided into 4 sections first. And within these sections, I'm going for each and every element over there. Apparel, electronics, and supermarket. This is how it happened here as well, right? Apparel, electronics, and supermarket for Chennai, followed by this 3 for Delhi, and so on, right? Any questions online, guys? Is there anything that you wish to ask? Classroom?
So what does dot represent?
Dot represents nothing. So there is no column that I am taking which will be dividing my data row wise, right? Let's say now in this case I'm going for 3 variables, so I have got it. Now let's say if I'm going for 4 variables, so you can accommodate one more variable in place of that dot. So dot is basically representing nothing, null. That's all about graphs. Two last things I'll be discussing. That would be your histogram and box. So for that, what I'll do is I'll take 2 examples. One, some random inbuilt data set so that I can have proper numbers. Switch off. Okay. So one inbuilt data set which gives me a proper example or a real-time example. The other will take the stores data set example. Now, to begin with box plot, or to begin with histogram. So histogram is your frequency distribution of your continuous variable divided into various bins. Now if you remember the process of binning that we had done, we had created 4 bins for my continuous variable called total sales, based on which I was branding a store as high performer, medium performer, average, or low performer. I had taken a particular range. I said 0 to this to that to this, and so on. Right? This is how a proper histogram works. Histogram, I'll show you one example. So the function I'm using to draw a histogram is hist. The base package function is hist. So I'll take stores. The only input to histogram function that you can give is a numerical variable. So I'll take total sales to hist function. Now look at this. It is automatically dividing my data into various categories, various bins. My first bin is 1 to 100. This is my first bin. 0 to 100 or 1 to 100 or whatever it is. And it says that there are 5 observations which lie between 0 to 100. Around 7 observations lie between 100 to 150. Around 4 observations lie from 150 to 200. 1 observation lies between 200 to 250, and so on. This is what a histogram gives you, a distribution of your data. Again, frequency distribution of your data, to be more honest. Any questions on histogram? Online guys, any questions? Now, if you remember the previous example that we had taken during binning, we said that 0 to 71 or 0 to 100, let's say, is low performer. 100 to like if I go for range of total sales, okay, it lies from 71 to 472. So let's say 100 to 300, average 300 to 500, good, 500 to, okay, it's 472, right? I'm so sorry. So 300 to 400, it's good. Anything beyond 400 is excellent, is high. Now, drawing a histogram directly here will give me n number of divisions which I don't need, I don't want to see. So that's the reason why hist function or histogram function will have an option called bins or breaks. Sorry, breaks will specify the number of bins in which you want to divide your data. So if I say hist stores total sales, so there's an option called breaks. So if I simply say breaks is equals to 5, R will take this as a suggestion. So there will be at least 5 breaks or more. There will be at least 5 bins, not less than 5 or more than 5. It can be more than 5 but never less than 5. So as you can see, there are now only 5 bars over here, and it has done it automatically. It understood the distribution is from 0 to 500, somewhere around that approximately. So it divided into 5 parts of 100 each. This is also fair enough on one side. And this is not that fair enough when we need a case like this, a custom ranges that we have. Now this can be also solved using the same breaks argument. Please pay attention. Going for custom breaks, I'll be using the C argument and I'll be passing on some range values. So here the number ranges are somewhat like this. It's starting from 0 or min of total sales. Yes. My next breakpoint is 100. Yes. After 100, my next breakpoint is 300. And then 400. And after 400, it's the maximum point. So it's max total sales. I'll be passing the same logic to my breaks argument within C function. Right? Small thing, it has to be stores dollar total sales. Min of stores dollar total sales and max of stores dollar total sales. Right? Now you see it. The division has been done automatically. So 0 to 100. Okay. One second. Okay. Yeah. With the 5 observations which lie from 1 to 100 and 100 to 300, there are more than 15 observations. So this is how it gets me. So it means that there are more average performance stores in my area, and happy news is that there are very less low performing stores. So this is how your histogram works. Any questions? No, it won't show min and max as such. It will be just creating. See, your binning, when we had done binning, it was also not showing any min or max. It was just converting, or it was just categorizing my continuous variable. Histogram will also categorize your continuous variable and it will show the frequency counts. How many observations were there? That's what it is showing. Yeah, no, it won't be showing min and max on x-axis. That's the only problem there. Now, coming to this thing, box plot. Again, we have already explained box plot. To generate a box plot, I have a function called box plot. So, of all the inbuilt data sets, there is a data set called US Judge Ratings. This is an inbuilt data set, one of the inbuilt data set, all numerical variables. And the reason why I'm taking this is, of all the data sets that I have seen, this data set has some outliers which we can easily visualize on the graph. So if I box plot US Judge Ratings, and always remember box plot and even histogram is for continuous variables, not all numerical variables. It's only for continuous variables. Please remember that. So like I had explained before, this is how your box plot looks. Your quadrants, min, max, upper count and lower count. And please look at these dots. So these are the outliers which you need to get rid of. You always have to get rid of these outliers before doing any kind of modeling. Linear, logistic, segmentation, clustering, time series, anything that you do, you have to get rid of these outliers first. And presence of outliers can be easily shown using a box plot. Draw a box plot before you do anything. Identify outliers. So in this I can say that like except this column here, this column over here, except these two columns, every column is having an outlier which I need to get rid of first, right? There's one level of information, quick information that you can get from a box plot. And needless to say, of course, we can do this for our stores. So if you just open stores data sets, look at the continuous variable present here. Operating cost is a continuous variable. Staff count, total sales, total customers, acquisition cost, basket size, yes. Profit per customer, yes, they are continuous variables. Own store, no, it's a categorical variable. Online presence, categorical. What? You're asking something?
I'm saying
Acha. Tenure is also categorical. Store segment is also categorical, despite the fact that they are numbers. I will just try to separate out these variables. Operating cost is my 5th column and profit per customer happens to be my 11th column. So I'll create a subset. So I'll call it stores count for continuous. Stores. So it's 5 till 11, right? These 7 variables are the only continuous variables. Okay. So if I do box plot of that, there is some outliers across my total customers. See, the data why you are getting the distribution like this is because the data points might be too small. The scaling might be too small. Yes, because total sales has a lot of stuff over here, like it's going to 472, whereas your basket size, profit per customer, and they're they're a little bit smaller numbers. That's the only reason why you're getting a graph like this. You can also draw individual box plots for those columns. You simply have to specify the columns in the box plot function. That's it. So let's say in this graph, your profit per customer is not clearly visible. Just draw a box plot for that one particular column using the dollar operator, and you'll end up with this. Clear? Okay. Okay, that's pretty much it. Your 6-day agony of R is going to end today.